So what if I had an equation that had this in it? Right, equals blah, blah, blah. What would be excluded from the solution set? 2. 0 would be completely cool, yes? So the idea isn't 0 is bad. The idea is the bottom can't be 0. So 2 would make the bottom 0. If I get 2 as an answer, I have to actually say no solution. All right, cool. Anything else, homework stuff? So try to put the last couple things in here. Let's see. You guys good otherwise? Oh, I didn't finish that. Let me get back some stuff. Lena. James. Goodridge. James. Kumar? Oh, that's you. Good comment. Abbas? Jimena? Or is it Zimena? Jimena? Uh-oh. Jimena. Yasmin is not here. Hiya, Jacob Hernandez. Jake. Christian. Alan.
6.
Mohammed.
28.
Alan. Daniel De La Cruz. Maddie.
Yeah.
Oh yeah, you and I. All right, so just see me after,
Yeah, because doesn't 3,
Melanie.
it's just when I set up like this is the horizontal.
And
Doesn't.
hey. All right, guys. Anything else from homework stuff? Much like you, I am. Don't have the most time in the week to grade stuff, so over the weekend, hopefully, I'm going to catch up with a lot of stuff. Maybe even. No, I'm not going to say that. Today's a long day, so more than likely, I won't do too much grading today. Those of you who just got your quiz back, real quick, there's a green grade. That's your original grade. There's a black grade next to the green grade. That's the curved grade, but I won't apply that until you try quiz corrections. So even if you get no points from quiz corrections, your grade becomes the black grade. And then on top of that, I'll add any points you get from the corrections. Yeah. Because overall, the average was like a 56, so I'm trying to do what I can. You got to work for it, but I'm trying to let you build that up. All right. Yes?
What does okay mean?
Means okay. So okay means you might have made a couple mistakes, but they weren't major. So you want to kind of find them and make sure that it makes sense why it was a mistake. Sometimes it just you didn't make any mistakes. Sometimes I'll put a check mark if you didn't make any mistakes, you know. But if I say okay or check mark, that means you got full credit. You might have missed a couple. You didn't do perfect maybe, but the couple you missed were nothing major, right? If I say correct, that means you have half credit. You can make corrections to get back to full credit. And when are those due?
Day of the exam.
Day of the final exam. Final.
Oh.
You have so much time to do homework corrections. I want you focusing on new homework. Do old homework as you can. Final's cumulative, so whenever you do it, it's going to help you, right? If I say redo, then you redo what you got wrong. It means you have no credit currently, but you can get back up to full credit if you do enough right. And again, same thing, just do the day of the final. And if I say no credit, no, that means you obviously copied from someone or something. Don't do it again, or else I'll just give you 0 for homework. Yes?
Is the study center having anything for math today?
Is the Math Study Center open? Is that?
Yeah.
Yeah, totally.
Oh.
Yeah. They're open, I believe, yeah, they're open Monday through Friday.
Monday through Friday.
We used to be open Saturdays back in the day. Yeah, that's when we had 20,000 students and we had a decent amount of money. Yeah.
66.
Is this on what? Oh, on
Chapter 2, I guess?
Yes.
Okay.
Oh, that one took me a while.
Is,
So
like,
no, no.
is it still, like, is it okay to, like, with, you know, when you're solving,
Oh, yeah.
when you're solving
Here.
for X?
I'll
like,
do a
you
example.
can cross, like, you can subtract something from both sides.
Yes,
something
exactly.
like that.
So
Can you
whatever
still
you
that?
do in an equation, if you do something to one side, you have to do it to
The other.
every other side. Correct. We normally only have two sides. So we normally just say do it to the other side.
Yeah.
But math, normally, like I told you guys, doesn't give a shit what the specifics are. It just applies these processes. So if I have an equation or an inequality, whatever I do to one side, I do to all the other sides. So real quick, just to show you, is this true? Yes. The quick way to say that is 2 is between 1 and 3, yeah? Or 1 is less than 2 is less than 3. If I only subtract 2 from these two, is that still true?
No.
Shit, no. So the only way to make it still true is do the same thing to all sides.
Okay.
So, for example, real quick, if I had 4 less than 3x plus 6 less than or equal to, you can do it, Jeff, 8, you would first subtract 6 from every side,
Oh, is it?
and then you would divide by 3, right? Yes?
If you invert the polarity on the numbers, don't you have to invert the polarity on the inequality too?
If I multiply or divide by a negative, then I have to switch the sign. Did I multiply or divide by a negative?
Well, on the top one, you sort of did.
No, here I just subtracted. And again, to remind you guys, that was a mistake, right? I was an illustration of why you have to do something to all sides. Real quick, why do I have to flip the sign when I divide or multiply by a negative?
Because then you can cancel?
So watch this. Which one is bigger? Holy shit. If I divide or multiply both sides by -1, what's -1 divided by -1?
1,
What's 2 divided by -1?
-2,
Which one's bigger now?
the 1,
What'd the sign do?
change.
So when I multiply or divide by negative, like we talked about earlier, doesn't that change the side of the 0 it's on? Doesn't that change the side of the number line? Doesn't that make the one that was smaller is now suddenly bigger? So if I have an equation like -x greater than 3 and I divide by -1, I must flip the sign. This is my favorite answer. Why? Because that's how numbers work, right?
Oh, I see.
It's only if you multiply or divide.
Right.
Only if you multiply or divide by a negative, then you flip the sign. And just to really overanalyze the shit out of this, so everybody's cool with, if I have this silly little equation, and I divide by -1, x greater than -3, correct? Separate little thing. If I say 7 is greater than x, that's the same thing as saying x is,
Less than
Less than
7.
seven.
these are just the same thing, correct? I'm older than you, you're younger than me, all right. So, watch this. I would never solve this equation like this, but let me just show you. Couldn't I add x? I could add whatever the hell I wanted. What would be left here?
0.
0. And then couldn't I subtract 3?
Yes.
Yeah.
-3 greater than x means that x is,
Less than 3.
didn't the sign flip for a different reason there? So it's a shortcut. If I brought the negative to the other side, the sign wouldn't flip, my variable would flip. So if I want to do the shortcut, did I just do that? I love that shit. If I want to do the shortcut and divide by a negative, the sign's got to flip. It's just a shortcut to doing this long ass thing, right? Okay, maybe. Yes.
With the inequality equations, do we just treat the sign as an equal sign?
No. So we haven't talked about absolute value inequalities fully yet. I think the last thing we did last time was absolute value equations, right? Okay. That might be a segue, but any other questions? Yes.
Is it possible for 66 the multiple inequalities to just break it in half? Because that's what I did. Shoot.
So if I have a problem like this, sure. I could say that represents this and this. And they can solve each one. The reason I find that, there's nothing wrong with that, except students will put the answers together the wrong way at the end. So if you take it apart, you have to put it back together at the end. Also, it's extra work. I'm going to add 1 divided by 4 twice instead of once. Right? But if it makes more sense to you to break it up, that's okay. I'm just trying to push you in the direction of you're going to do the exact same math, just less of it, if you keep it as one. I call this a sandwich. Right? Isn't the 4x minus 1 sandwiched between 2 and 7? Just keep it as a sandwich. By the way, if I solve this, so add 1, I'm just going to do this real quick, divide by 4. Is that cool?
Yeah.
How would you represent the answer in interval notation? Good. Don't include parentheses. By the way, remember back in the day when you would graph something, if I said x greater than 4, what symbol would you put on the 4? Closed circle or an open circle?
Open.
Open because it doesn't include 4, correct? So isn't a parenthesis, doesn't that look like part of an open circle?
Yeah.
All right, that's why parenthesis means don't include, right? So this would also, so what if I had this instead? Everybody make it this, just because. What symbol would go on the 2 now?
Is that what they're called?
Bracket.
Oh,
And what does that mean? Do I include 2?
yeah.
Yeah.
What's the first letter in the word include?
In. No I.
I love you guys.
God.
I, right? And doesn't an I look like it has a bracket in it?
Oh.
So bracket means include.
Huh.
Looks like the letter I, part of the letter I, that looks like part of an open circle. Don't include, include. Right? And then to plot it, you would put 3/4, 2, same symbol, sandwich. Right, there's the jelly. And when I teach this, I teach it using Dragon Ball like. Anybody? Like that, and then it shoots out. Okay. Should get that to myself, but that's too bad. I just like to see if anybody knows what the hell I'm talking about. All right.
Z.
Huh?
Dragon Ball Z.
Dragon Ball, yeah, exactly. Z or whatever flavor you like best. Heroes, superheroes, blah, blah, blah. Okay. No, Dragon Ball is not a prerequisite to the course. You're fine.
It should be.
That would be funny. Anything else from homework stuff? Yes.
54?
Yeah. All right. In general,
It just freaked me out in general.
that's the one with the cubes and stuff, right?
Yes.
Okay. Okay. All right. Now watch this real quick. This is going to seem silly, but oh well. If I had to solve this, you could do it, Jeff. Yeah. If I had to solve this, that's easy, right?
Yeah.
I would add 8 divided by 2, be done with it. Can I solve this the same way?
No.
No, because I can't get my x's in one term. That's nice. I can get my x's in one term so I can kill the 2 and I'm done. If I could get these in one term, I could do the same thing. Not like terms. Shit. So anytime you have a higher power than 1 on your variable, you're almost always going to want it to get equal to 0. We talked about y yesterday, I think, right? If I know 2 numbers multiplied by 0, I know something. And then what do I do with this, though?
You have to factor it.
Factor it, so I can see what 2 numbers equal 0, and then I know one of them is 0, correct? So look at your problem. How many terms are there that are equal to 0?
2.
Isn't it 4x cubed? Right? Isn't it this one?
Yeah.
8x squared. Is it minus?
So, wait, so then,
How many terms?
4.
1, 2, 4, right? Terms are separated by plus minus. Is everybody with me?
Yes.
Factoring methods is determined by how many terms you've got. So you need to be able to count the terms. If I have 4 or more terms, do you guys know what method to use to factor it?
To
You do 4x cubed.
Grouping,
Yeah.
yeah.
Ooh.
Real quick, some of you guys,
yeah.
your teachers have shown you to put parentheses, and that is not great, because if I put a parenthesis here, didn't I take a negative out?
Oh, yeah.
So some of you guys are making negative mistakes, so I'd have to change the sign. I just underline the damn things. There's no reason to put parentheses in there. There's a problem, right? Take a GCF. There's a problem. Take a GCF. And then you can see if you can do the last step for factoring. And then you have to set everything equal to 0. Is that all right?
Yes.
I like this problem because there's 2 more steps on the factoring. Yes?
Go a little bit further with that one.
I don't know. I don't really want to, but yeah, what comes out of these 2?
A 4x squared.
Good. 4 comes out, 2 x's can come out. What's left here?
An
X.
x plus 2.
Good. Well, let's see. What comes out of these 2?
Negative 9.
Very quickly. So many problems have hints in them. In order for this to work, I need there to be an x plus 2 left here.
Oh.
So without even looking at this, I know I have to take a negative 9 out so that I get an x. Right? So this is always a hint. But I mean, this is pretty simple. You can see negative 9. What's left?
X.
X plus 2.
What if I do this mistake? Could I do the next step?
No.
Because these are not the same. And normally, the mistake made there was a sign mistake. Now you can do the next step, which is what?
Distribute.
Combine.
If you distribute, you go back.
Combine,
Oh, yeah,
combine your like
combine.
terms.
No like terms here.
Put the x plus
4x.
2 and then 4x.
Yeah, you
minus
can take
9.
an x plus 2 out.
And then 4x squared minus 9.
Because if I take an x plus 2 out, I'm left with 4x squared minus 9,
Oh, I
correct?
see, yeah.
Yep, that's all we're doing. Do you see how this is that done?
No.
4x squared minus
No,
9?
because then the 4x.
That's all I'll do. That's all I'm gonna do for you. You gotta do one more step here, of course, right?
Yeah.
So if I said
Yeah.
completely factor 18 and you said 6 times 3, are you done?
No.
No.
Because 6 can go further, so this isn't done yet. This can go further.
Okay.
Okay. And then you just apply the idea that I don't care if I have 3 numbers multiplied by 0, what's got to be true when I have 3 numbers multiplied by 0? One of them has to be, if I have 3 numbers multiplied to be 0, one of them has to be
Negative.
0,
Oh.
right? That's the only way you can have 3 numbers multiplied by 0 is if one of them's 0. Does everyone agree with that?
Yes,
If you
yes.
disagree, show me. Show me 3 numbers where none of them is 0, but the product is 0.
I'm not raising my hand to disagree, by the way.
Teach me. Yes.
So when do we do the little parentheses and the big parentheses? I thought we do that when we have cubed.
What tells me? The fact there's a cube doesn't tell me this is in the form of cubes.
Okay.
It's just the same way the fact that there was a square here doesn't mean it's a difference of squares, right? How many terms are there for squares and
Okay.
cubes? 2.
So it matters on the terms.
Also, there's a cube there, but can you break everybody up into 3 parts? No.
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 Okay.
So there's got to be 2 terms, and for it to be cubes, everything has to be able to be cut into 3 parts. Then you got the little dude, big dude. Yeah. Okay. I kind of want to show you something. Yeah, I'm going to show you this. It just came to mind. And then we're going to get into some new stuff. Let me see. That's right. Okay.
Let's see if I can do
So this is basically the question we just had. We just made one that would work. One way you could answer this question is to add 27, and then what do you do to both sides? So if I add 27 to both sides, yes?
cube.
How do we get x by itself? Take the cube root, right? And then you would get one answer. Can anyone tell me why that should trouble me that I only got one answer?
Because you can't wrap it.
No? What's the
Isn't
highest
it-
power in the problem?
Three.
Third degree. So how many answers should I get?
Three.
3. Where are the other 2 answers? That is the real answer to this problem. What's the correct way to solve a problem like this?
Do the little big.
Factor.
Little.
Yeah. So, nice little memory thing. X cubed is
X times X times
27.
3 times 3 times 3.
So 1 of each, right?
Uh-huh.
Same sign. Because he's a poor little dude. He can only fit 1 of each. Big dude, more room. I put the other 2 X's and the other 2 3's, right?
X. And then don't you combine the.
What sign
little
is this
dude-
going to be?
Oh, yeah,
You combine the little dude and then do the opposite sign.
So,
3x.
3x.
There, that's how they all work. 1 of each, 2 of each, product in the middle. That's the closest to a song I'll get. Okay. So a lot of math is a lot of songs, and songs are great. Songs are great. I obviously enjoy music, but they just make things seem like, oh, I need the song. No, you don't. This, well, watch. I have number times number equals 0, correct? I do still get 3, like we got a second ago, correct? Of course 3's got to be part of the answer, because 3 cubed is 27 minus 27 is 0. But I get 2 more answers. How do I solve this part? Quadratic formula. X equals
The
negative
opposite of B.
b
Oh, I
Plus
forgot
or
the
minus.
formula.
plus or minus
the
square root
of B
b
squared.
squared minus.
Minus 4 times A times C all over 2 times.
Right, yeah, okay. All over twice a.
Yeah, I used to have that memorized, now I don't. Gotta refresh my skills.
I used to always joke that when I get really, really old, that's all I'm gonna be walking around. Negative b. Getting closer and closer. That's right. Negative 3 plus or minus 9 minus.
9.
No.
Wait, 9 minus,
36. Negative 3 plus or minus
sorry.
square root of negative 27. Yes. Yes.
Yes.
Yes. Okay.
Yeah.
Take this up here. Jaws, Jeff. All right. So, negative 3 plus or minus. Can somebody please? This is not a good place to stop. You're not done. Simplify this. Watch this. You ready? Anytime I have a negative, what's the square root of 9?
3.
What's the square root of negative 9?
3i.
3i. So what would I do with the square root of 27? Wouldn't I break it up as the square root of 9?
9i.
3. I like it. And what's the square root of 9?
3.
Just 3i. Yeah.
Okay, I like it. Now real quick. I'm gonna go one step beyond where we need to. Just want to put that out there. So the answer to this question, there's 3 answers. 2 of them are not real. One answer is right here, correct? Another answer
Is in the I.
is negative 3 plus this. It's here. Negative 3 plus I blah blah. Negative 3 halves plus minus. And then the other answer is going to be negative 3 halves minus that down here. The really neat thing is the angle between these two, the angle between these two, and the angle between these two are all the same. That's the step that's farther than we have to worry about. But we just talked about the real number line and the imaginary number line, so I thought I'd show you. Fundamental theorem says there will be as many answers. So if this is a 4th power, there's probably an answer. There could be an answer here, 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 and here, or here, 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 and here. 5th power, there'll be 5 evenly spaced answers. So visually, it's really cool. You get a 1 answer, you can just kind of rotate as many times as you need to get all the other answers. Right now, we don't know how to do the rotation, right? So right now, I can just show you that's what it would look like. Do you guys ever have to do this when you know you don't, right?
Is that how a computer draws a polar array?
Sort of. Not really.
Draws a.
This is just more of a, not an abstraction, but this is the imaginary line. So normally on computers, I would represent that as a color. So like if you ever see, anybody ever heard of the word fractal?
Yeah.
Yeah.
So very often, very many fractals are actually graphs of complex answers to solutions. So the black areas are the more complex, and the lighter it gets, the less complex it gets. So that's why it's got a lot of colors in the picture. Enough of that. Okay, all right. That was beyond what we had to do, but oh well. All right, let's get back into kind of like where we left off. To finish up chapter 2, we basically have just a couple things to do with chapter 2. So remind me, how do you solve this kind of equation here?
Square.
Yeah. So most equations, you say to yourself, why is x not by itself? Or what do I wish wasn't there? So in this case, why is x not by itself? The stupid square root. So I just do what I can to kill it, right? Woohoo! What about this? Sure. There's a square root, so you know you want to eventually square. Do I want to square right now?
Yeah.
Because if I did, I know some of you guys are going to square this piece and square that piece, but you know better. If I square this side, what do I have to do to the side?
The other.
The
Oh wait, distribute.
I got to FOIL that crap, and doesn't the radical still stay alive in the middle term? Oh, that would suck. So what's the better first step? I always call this my my class in how to be a tyrant. So what does a tyrant do? They isolate the radical element and then they kill it, right? So how do I isolate the radical? Add 1.
1 both sides.
Add 1. So I get rad 2x plus 3 equals 5. And now I can kill the radical element.
No, don't you want to make the 5 a 0 first?
No. Okay. So I only need a 0 if I have like something I can factor,
Oh, I see.
right? So if I had this, I would want to bring the 4 over and then I can factor it. This, I have a symbol that actually I can kill directly. If I just square it, I can kill it directly. I don't have to do any like sideways kind of work. What can I do to this directly? I can just square, because that kills that, which frees my x. So from the very beginning, the worst part about this equation was I have an x that's stuck inside of a radical. How the hell could I get it by itself then? Well, I get to a point where I can kill the radical. 2x plus 3 equals
25.
25, and then a couple steps, right? Subtract 3, 22, divide by 2, 11. How are we all doing?
Good.
Good. Now, just to get you ready for what could happen, can anyone tell me the answer to this equation without doing any work? Or, yeah.
That would be 81. Right? Oh wait, no.
What is
Wait.
the go ahead, yes.
-1?
No.
Oh, just the answer.
A square root must always come out. How? A square root is actually, by definition, a square root comes out positive, always. You guys with me? So what's wrong with that equation?
Oh.
What's it want me to figure out? When does this square root equal a negative number? I know the answer. No solution. This sets up a bogus thing. A square root can't be negative.
Bogus.
Sort of like, look at this equation. I want a number that when you add 1, I get that number adding 2. Is there a number you add 1 and it's the same as if you added 2? Is there any number that does that? Can I add 1 to something and it's the same as if I added 2 to it?
No.
Ain't no damn number that does that. So I know the answer to this is no solution. And if I try to start solving it, I see no solution, right? 1 equals 2, no. If I try to solve this, right? Hey, x equals 82 divided by 8, x equals 41 over 4. If I plug that in, there's no way it's going to equal negative 9 when I go to check it. But if you don't even notice it, are you even going to think to do that necessarily? No. So that's why I try to tell students, anytime you have a radical equation, you really should check your answer. Yes?
So if that were like on a quiz or a test, would you want us to do all the work and show you how we know it's not true?
No,
Or
I
can we
love
just
it. If
look
I
at it and
gave
be
you
like,
exactly this question, I'd get a little tear if you just put square root can't be negative, no solution.
Okay.
That would kick so much ass, because one of my favorite little phrases I use is, the more you know, the less you should have to do. Right? So that's your work. Your work is your explanation. There's no work to do. Can't happen. I'm done. Next. Okay. Now, the ultimate level for these. The final form, let's see. It's not really the final form, to be honest. So what if I had this thing here? Oh shit, maybe I should make it work. Hold on. Okay. Okay, I think that'll work. Maybe not. Hold on, sorry. All right, it's kind of weird to try to create one that'll work. Let me think. Okay. Yeah, so it should just, yeah, there we go. Okay, that'll work. Okay, sorry. There's something different here than the ones we've been doing. There's x's, there's one in stuck, and there's one that isn't. But I still apply the same idea. I isolate my radical element, and then I kill the radical, correct? So what's the first step?
Add 3 to both sides.
Okay, I like it. So remember what I said? We have a process, and the process doesn't give a shit about what the particulars are. So the process here is get the radical by itself, square both sides, keep going. So we care as a human. I care the fact that there's a freaking x there, because when I go to square both sides, what do I have to do? Here's a really common mistake. I have made a mistake. Don't write that. That is a mistake. What mistake did I make? Some of you guys are like, it's good to me, man. How do I square something?
Oh.
Multiply it by itself.
Then you have to do the square root again.
No. How do I square something? Multiply by itself. So what was I missing? I was missing the middle term, correct? So in a problem like this, you're sort of so stuck on the fact there's a square root, you forget that when you square something, you have to write it twice and foil it, right? So what do I get there?
X and then 9.
Right? Now you get to really be excited. So you're like, okay, this was a radical equation. Now it's a factoring problem. You guys see that?
Mm-hmm.
Not quite yet, though. What do I have to do first? See a higher power than 1?
Yeah.
So I need to get it equal to.
0.
So what do I have to do?
So then you have to add all that to the other. Subtract it.
Subtract x.
Yeah. Plus 1.
Add 1. Subtract x. Add 1. So we get 0 equals x squared minus 7x plus 10. Go ahead and finish that out. I'll wait. That one's not too bad, right? Not that many ways to factor 10, so what do you guys get?
5 and 2.
5 and 2.
But it's
Negative,
2, right?
negative.
Oh, both negative?
So you make negative 7, and you
Oh.
multiply via positive.
Uh-huh.
So what are your two answers?
5 and 2.
Now, if you circle that, you're going to lose points.
Because don't you?
One of them doesn't work. Let's try them out. Let's try them out. Let's try 5. Square root of 5 minus 1. Holy crap, what was that?
Yeah, because you have to check to see if one of them's going to match.
What's the square root of 4? 2 minus 3. 5 minus 6. Check. Now you guys check 2. Check 2. Put a 2 in.
Why do you write to check?
So since radicals are so uptight about the kind of numbers that they have to come out and can go in, you could get answers that don't work. And then I really want to show you why, because as a student, I wouldn't blame you for like, if I do all the math right, why the shit do I get answers that don't work? Has anyone ever thought that?
Yes.
I don't blame you. That's a beautiful thought, and I want to show you why it's not math's fault. You know, like math apologist, whatever. All right. So what are you getting for 2? Does it work?
No.
Square root of 2 minus 1 minus 3 equals 2 minus 6, right? Yeah. 1 minus 3, is that 2 minus 6? Is negative 2 equal to negative 4?
No.
No! I like it. So, your answer would be 5. So you have to show me this was a possible answer, and then you have to show me a cross out. Don't just write 5. Write me both, and then cross the bad one out. And they both might not work sometimes. You can get no solution, you can get 2 solutions. I want to come back to this step right here, before we squared. This is the square root of something equals x minus 3, correct? If x is 2, doesn't this say the square root of something equals 2 minus 3, which is a negative number? So that would have been no solution. If I would have saw that this was a negative number, I wouldn't even have done any work. We don't know what the shit x minus 3 is until we've done the work. Do you guys understand what I'm saying?
Yes.
If I see a problem is the square root of x minus 1 equals negative 2, I'm not going to do shit. I'm going to say no solution, can't be negative, right? I'm not going to do any work. But this, until I know what x could be, I have no idea that this would be negative. So when we squared, if this was negative, didn't we just lose the negative? All right, so the process of trying to solve it kind of like undid the negative, so it made it look like there was more answers. So it's not math's fault. Math is like, I answered this equation, but it doesn't work for the original. Okay, maybe? So again, that's why you have to check your solutions when you have a radical equation. Yeah.
Oh, I was just about to ask, when do you check? Only radicals?
Well, I mean, you can check every damn thing in the universe, but when do you really have to check? One situation is radicals. The other situation we saw earlier, if I have an equation with like 3 over x minus 1 in it, what could x not be? So if I get x equals 1 at the end of my stuff, I cross it through and say no solution, right? So those I have to check to make sure they don't freak the equation out. Okay, maybe. Yes?
Is there a difference if we put undefined or like no solution, or is that?
Undefined is specifically when I'm trying to simplify a number. No solution, because the question says solve this. So undefined doesn't make any sense. No solution means, okay, you didn't find a solution, right? Does it make sense? So in this case, x equals 1 is not a solution because it makes a part of the equation undefined. So you wouldn't just say undefined. It doesn't make sense. You would say no solution. Is that all right? Okay. I know there's a little bit of semantics, but you know. All right. How you guys feeling? I'm hoping that this is mostly review and it's kind of coming back up. It's been a little while maybe for some of us, and again, some of us might need more review. That's okay. Yeah.
Wait, why is x minus 1 and we get no solution?
One. If I did the work and I got x equals 1,
Oh, okay, so then it would be 0.
then I have to throw it out and say no solution. Yeah. Any other x would work, or could be a solution, but 1 couldn't be.
Is there a way to write that where it's like anything but 1? Or do you just write no solution?
Yeah.
It's just.
You guys remember this?
Oh, yeah.
Ew, I don't.
I look at this as saying skip. From negative infinity, skip 1 to infinity. That's all it means. It could be any number in here or any number in there. So what's the only number I'm skipping? 1. That's it. That's all it means. Interval notation, right? Why do you not put a bracket on the infinity ever? What does bracket mean?
It means
it
including.
means
Including, so if you put a bracket on infinity, I want you to bring, the next time I see you, I want you to bring infinity to me. Because you just said you can get there, right? If you include infinity, you can bring it to me. That's my thing about Pulp Fiction. I think that's what's in the briefcase is infinity. Oh. Again, not a prerequisite for the course to watch Dragon Ball or Pulp Fiction. It's fine. If you don't get any of my references, it's fine. Just hopefully get my math. Anything else about this year? Yes?
When I learned inequalities a while ago, they had a certain way we would graph it. Is that going to be a thing in this class?
Totally.
Oh, okay.
So I love it. It's like I planted
never
you.
fully grasped it or understood.
It's like I planted you out there because the next thing is inequalities. So the most fundamental thing about inequalities we already discussed. If I try to start solving an inequality, it's going to be exactly like solving an equation except for one thing. Does anyone remember what that one thing is? We did it earlier.
There's multiple answers.
Sure, there's an infinite number of answers, but when I divide or multiply by a negative, I have to
Flip the sign.
flip the sign.
Oh.
Okay. So one way to solve these is just to try to make sure that your x's never have a negative coefficient. So I could subtract 3x, correct? Right?
Yes.
Wouldn't that make a negative coefficient? So it's completely up to you. You could solve every inequality and try to not let your x's become negative. Then you never have to flip the sign. But the trade-off is your x's are now on the other side. Right? 6 less than or equal to x means that x is,
Less than or equal.
no, 6 less than or equal to x means x is
Greater than or
bigger than or equal to 6. So you just have to mirror image it, correct? The other way to solve this, and I know I'm going a little fast. We're still in the review stuff, so I'm going to go a little bit fast. If I subtract 3x and subtract 1, I'll get negative x less than or equal to negative 6. If I divide by negative 1, flip the sign, I get the same answer, yes? Now how do I graph this?
You have to do it's a closed.
Nope, we don't do circles anymore. We do set notation symbols. Do I include the 6?
Yes.
So I'm going to,
Yes.
it's allowed to equal 6, right? So I can include it. So I'm going to make this is another way to look at it. If it has a line, then I'm going to use a symbol that looks like lines, yes? Line, not the curvy dude. Or include, this looks like an I. Which way do I open it? The direction that I want to shoot the stuff out.
It's greater than or equal to 6. If it was less than or equal to 6, it'd go the other way.
Exactly. I love it. How do I write that interval notation? Interval notation is basically from, comma, to.
Parenthesis.
Bracket.
Use the same symbol, right? I include 6, and I go up to
Infinity.
Oh.
And then the parentheses.
beautiful. Please, dear God, what would you say to somebody if they put that? Don't put that. Don't put that.
That's what the arrow means, right?
That's what the arrow has to mean. There's no way to find infinity on the number line. Does everybody agree? Because if you think you found it, what the hell's that? Right?
Infinity and 1.
Funny thing about infinity,
And beyond!
there it is. It was buzz. It was buzz. I love it. All along. You guys with me? Is that all right? Maybe, yes?
So I did it like this. It's like the same thing.
Yeah, that's how I was taught. We had to like shape
Not for
it.
this question. It's for like a homework question. But I
You
just
only
changed it.
have to do 2 dimensions if you have a 2 variable equation or inequality.
Okay. So do you want me to do it like that?
Dude, they have-
There's no, all right,
What are they doing right
if I have this, which we will eventually talk about, the answer will look like a line, and I'm going to shade one side or the other.
now? See, that's
This
what
is
I-
one-dimensional. This is two-dimensional.
Oh,
You guys kind of with me? Okay.
so we do have to shape.
So unless they specifically say, graph this in 2 dimensions, there ain't no damn reason to graph this in 2 dimensions. Is that all right? So whoever, you might be thinking about when you did a problem like that and thinking it applies here too, I don't know. Okay, yes.
So why did you put the parenthesis after the degree?
What do you think should go there?
The bracket, because it's
Can
from
I-
6 and beyond.
Can you get to 6? If you're standing at 0, can you get to 6? Yeah, I can get there. Hey,
Yeah.
6, how you doing? If you put a bracket, you're telling me you can get to infinity.
Yeah.
What is infinity?
Infinite.
No,
Like
you
it.
can't use the word to describe itself.
Oh.
What's a chair? It's a chair thing.
Oh my
Forever.
I like it, forever. Is infinity a location or a number?
No.
Hell no, infinity is just a continuous process. One way to define infinity is say start at 1, now add 1, now continue forever. And there's some guy, plus 1, plus, it's just never gonna end. You with me? So infinity is a process. I cannot include a location that's not a location. This is not a location, I can't include it. Just keep going, you never get there. Yes?
Okay, I have a question on how you did the problem. So why did you do minus 3x on both sides and not minus 2x?
No, that's the way I did it first. I did this problem twice,
Okay,
right?
okay.
First way I did minus 2x. And then the x was on the other side, so you just have to be cool with flipping it. Or if you want to keep your x's on this side, you just have to be cool with flipping the sign if you divide.
Oh, okay.
So like.
You can do either way, guys. That's why I did it both ways. Either way.
Okay, so either way would work.
Of course, I got the same answer both ways, yes?
Yeah.
That's what I was trying to show you. I got the same answer either way I did it.
Okay.
Yeah. Okay. All right. I think, yes. Now, the only thing we have left in chapter 2 is absolute value inequalities.
So the two-dimensional ones aren't really gonna be like.
Later.
Oh, that's
I don't
later.
think they're
Okay.
here yet. Let me see,
Oh, okay.
unless I missed it. Give me a second.
It's like stressful.
I'm pretty sure that's coming up later. Yeah, I don't know if you're having nightmares about that.
I am.
I understand.
do every night.
I don't think we've gotten to,
Okay.
when does it come in? It does come in eventually. I'll just say it's not yet. Yeah, okay. So somebody remind me, how do I solve this equation here?
Oh, it's,
Don't look back
Hold
at your
on.
notes. Don't,
Oh.
stop. Just say to yourself,
But I forgot.
the absolute value of what is 11? What do you take the absolute value of to get 11?
11 or negative 11?
There.
Oh.
So make this less about memorization and more about just understanding the idea. I'm able to do a lot of math, but I have nowhere near that much math memorized, right? So I feel really bad for students who seem to think that you have to be able to memorize everything. And sometimes a student feels like every problem is its own thing. And I try to keep telling you, this problem is the same as 8 billion other problems. They're all the same problem, right? So there's basic underlying ideas that you get to know, and then it's not memorization, you just do the right thing, right? You don't have to memorize not to put your hand on a burner. You go, oh, I forgot. Oh shit, what am I doing? Okay. You just know not to do it, right? It's just the right thing to do. Depending on what you're trying to do, I don't know.
That's just the answer. Okay.
So what if I had this? Let me see if you guys think about this. Now remember, what did we do when we were solving a square root equation? What did I have to do first? Get the square root by itself,
-1.
right? So almost every equation, I want to find where my variable is and get that piece by itself. So where's my variable?
In the absolute.
I want to get that piece by itself.
How do you undo an absolute?
Well, I'm not there yet. I don't have to worry about it. I just
Oh.
have to get that by itself. What do I want to get rid of then?
Oh,
The
four.
negative
Minus 1, correct?
Oh.
All right.
Oh.
Add 1, add 1. So
Yeah.
this says the absolute value of something is 10. I really want you guys to get this. What could I replace x plus 4 with, and that would be true? What could I put into it? I could either, no, not x. What could I
Oh.
replace x plus 4 with?
Oh.
I could either put a 10 in here,
Uh-huh.
or
Or a negative 10.
negative 10. So in general, to solve absolute value equations, get the absolute value by itself, the stuff inside equals the number, the stuff inside equals negative number. Solve both.
Okay.
So I get x equals 6, like you said. I get x equals negative 14. And then you can check it if you want to. You can leave your friends behind.
Oh, yeah. I remember this.
Okay? All right, so, and just to show you something, do you remember the absolute value is distance? Let me put this, no? Let me put this problem down real quick. What this means is, this would be all the numbers that are 2 away from 3. So this is the distance from a number in 3 is 2. That's what that says. I would never make you solve it the way I'm about to. I just want to show you the idea, right? So what number is 2 away from 3? Give me one number that's 2 away from 3.
2, 1,
1 is 2 away from 3, correct? What else?
5.
5. So how many answers did we get to a number that is 2 away from 3? We got 2 answers, didn't we? All right, so now let's apply the idea. Either x minus 3 is already 2, in which case the absolute value is 2, or x minus 3 is negative 2. What do I get when I solve?
5 and 1.
Freaking 5 and 1, of course, right? That is the idea behind the work. Yes?
Yes.
Okay. You never have to do this, but it's good to see that explains why you get 2 answers, because it could go left or I could go right. Okay, I like it. Now, what do you guys think about this problem?
Obviously, can't just look at that one.
Yeah, this one would be really hard to do this. We don't. So it's easy if you have just X and stuff, then it's easy. But
Subtract 9.
okay, good. First step, subtract 9, correct? See if anybody remembers from earlier.
Oh, it's a negative.
So what does that mean?
The absolute value can't
Yeah,
It's
no
not
solution. We
possible.
know there's no solution already. Do you see that?
Yes.
Could you
Oh, yeah.
do the 2 cases? Could you get 2 answers all day? They wouldn't work. Yes.
So you can't take numbers out of the absolute values and put them to the other side? Like you can't add the 11?
Let me just say like this. No. Well, okay. Adding 11, shit, no. You could not. Listen, look. Is the absolute value of 13 minus 11, is that equal to 2?
Yes.
Yes. Let me see, which way do I want to do this? I'm going to show you why in general that's not good. Oh, let me do it. That's right. There you go, John. Now you're cooking with gas. Is that true? That's true, yes?
Yeah.
9 minus 11 is negative 2. Absolute value negative 2 is 2. Okay, everybody with me? Now, if you could just add 11 to both sides, you would get this.
Oh.
So again, I shouldn't even have to go there. I can't break into something. Like if I have square root of x plus 3 equals 9, if I have this, people wish you could do this, but you can't.
Oh,
You can't
yeah,
break
yeah.
into a square root. You can't break into an absolute value. Is that okay? All right.
Is there in their house?
Exactly. All right. So this, again, right here you can just stop and say no solution.
And that's because the 2 is a negative.
Yeah, absolute value can't come out negative. Okay. All right. I like it. Okay. And again, just to remind you guys, we're still in the review phase. I know things are coming fast at you right now. We're still there. Last thing about chapter 2. You guys think about this for a second. In fact, let me make this a little bit better. Make this, believe it or not, this is better. Okay. This says, I want the distance from 1 to some number to be at most 3. I want to get at most 3 away from 1. So how far up can I go? To what number? 4. And how far down can I go? Negative 2. But wouldn't everything in the middle of those work?
Yes.
At most 3 away. So this is at most 3 away, this is at most 3 away, 4 is at most 3 away. I just can't include anything outside of there, right? So then wouldn't that be the answer right there?
Yes.
Now, is every problem like we just saw? Can you make a visual of every problem? No. So the visual's nice to kind of get things rolling. What would the algebra look like for this? So here's the idea. I like to call less than, it's like a haunted house. So have you guys seen enough scary movies, horror movies? What's the worst thing to do when you're entering some unknown area? Split up,
Oh,
right?
yeah.
That's the mistake almost everybody makes nowadays. Also, for some reason, cell phones are working on this kind of shit. So, horror movies back in the 80s, we didn't have cell phones, so it was a little more believable that they couldn't contact anybody. But you go to the haunted house, you want to stick together. You want to stick close to each other, right? So maybe you want to get at most 3 feet away from each other. You with me? So does it make sense if I'm here, don't I want you to be at most that far and at most that far?
Yeah.
Maybe ahead of me, behind me as we go down this little hallway, right? I'm imagining Scooby-Doo now, I'm sorry. You guys kind of with me, right? So, what the shit does that mean in terms of actually working anything out, Jeff? Okay, well what that means is I want this to go at most up to 3. Did I go at most 3 steps up?
Yeah.
Yeah.
Didn't I also go 3 steps down?
Yeah.
So I want you to stay close to me. So it makes sense that a less than absolute value inequality is going to end up with a sandwich. I don't want you to get away from me. I want you to stay close to me. Don't go too far up. Don't go too far down. And I already know the answer. This is the answer. How do I solve this equation?
You have to do the plus one.
Plus one.
To
All sides.
To the other sides.
And not surprisingly, I get -2 to 4, right?
Mm.
Maybe?
Yes. And that's if it's greater than or equal to or less than or equal to.
No.
Oh.
That's if it's less than or equal to or less than. That's
Oh.
in fact, I mean, there's not the most sense to say this right now, but it's less than. so this is
Oh,
this
less
is
than.
this and this at once.
Yes.
So that's why it's sandwiched.
Less than.
Less than. So you can't go too far up and you can't go too far down. That's why you're stuck inside, right? So haunted house, less than, haunted house. I want everybody to stick close. I expect the answer to look like a sandwich. I don't want you to get too far away from me, correct? And I apologize ahead of time if this is too real of a, let me not do that, let's do this, of an example, but great tour is like a restraining order. How does the restraining order work? So, and I'm really sorry if anybody knows all too well.
You
how that
have
works.
to stay back a certain.
You have to stay away a certain amount. So wouldn't I want the picture to look like this then? If
Yeah.
I'm in the middle, I don't want anything shaded until I'm way over there. Just stay the hell away from me, right? You with me?
Yeah.
One semester I had one student in my class have a restraining order against another student in my class. That was exciting.
That's foul. Wait, were they like this side and then this side?
I don't know. Whatever it was, they worked it out. So I didn't want to get involved beyond just knowing. Like, just shut up, sit down, and let me teach.
That's crazy.
Yeah.
'Cause-
I know. That's all. I'm sorry. It's
So
too
you
much.
have to see like an opposite.
So real quick, this says that I want to get, the distance from 4 to the number has to be more than 7. So how far up am I going to go? 7, right?
Yeah.
And it's going to be more than that. And then how far down am I going to go? I'm going to also go 7 down. And then I want it to be more than that away. Yes? Okay, I like it. You guys are doing great. So I already know the answer. And again, you're not going to be able to draw a picture for every problem. They're not always going to be all that nice, right? So how does this work then? Great tour. 2 separate things, correct? So either x minus 4 is greater than 7, or x minus 4 is less than -7. So I want to go up by 7, or I want to go down 7 steps, right? See, when you have a greater or greater than or equal to inequality with absolute value, or you're going to have 2 separate things. So one is just itself, and the other one is that. So real quick, let me ask you guys. I should have done this first. That's easy, right? You can let's solve that, and then we'll see you get the same answer. Blah blah blah, right? Add 4, same answer, right? Less than -3. or greater than 11. You get the same answer. Yes? So conceptually and algebraically, same answer. Always good to see. All right, I get the general feeling you guys don't like that too much yet, but all right. Somebody tell me a number I can put in here to make that a true statement. Just tell me a number I can put in there. 8?
Yeah.
Is that true? Yes. Somebody else tell me a negative number I could put in here to make that a true statement.
10.
Yeah, so for example, what wouldn't work? What negative number would not work? Negative 6, negative 5,
Yeah,
right?
anything below 7.
Do you see why greater than 7 works
Uh-huh.
or less than negative 7 works? The size of the number itself has to be bigger than 7. So you have to go above 7 or below negative 7. I'm trying to show you why those two cases make sense. Maybe? Okay, maybe. I always feel like half of you are like, okay, and the other half is like, oh, I have no idea. So if you're in the I have no idea camp, you can always come see me, right? Okay. So we are gonna take a few steps into chapter 3 for damn sure. Chapter 3 is all about function notation, that kind of stuff. We're gonna look at some graphs of functions, really exciting. Do you guys remember what I told you about pre-calculus?
Yeah.
Hopefully you didn't take this the wrong way, but I call it calculus, I call it graphing hell in a way, because we're gonna be graphing the hell out of everything. We just are, so just be ready. If you don't have graph paper, you probably should get it, just to let you know. So, if I write this down, does everybody feel okay about that? Does anyone know how to read that?
I don't know what's in the front.
Oh, okay, okay. Does anyone know what this is called?
F of X.
Okay, so the way to read this
F of
is
X.
f
Oh, it's just
of
F of X. Oh, okay.
x is 4 minus 5x, blah, 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 right? So f of x. It does not say f times x. In fact, how do you say this? Just say this to me.
Square root 9.
Square root of 9. So what is the function? Square root of the thing I put into it. Yes?
Function of x.
You guys with me?
Uh-huh.
So if I had this, would you solve it by dividing by the square root symbol?
No.
I've had people do something sort of like that, which is always neat. Right?
Wait, what?
Bless you.
What the heck?
I know. So the answer is 7 divided by the square root symbol. No. So you can't divide this by f for something silly. This is one thing. F of something is 4 minus 5x. So it just defines what I have to do to a number that I put into it. Bless you. Which is why we call those inputs, because we put the number in.
Yes.
So, for example, can somebody tell me what f of 2 is? What does that tell you to do?
It would. plug
Instead
in
of x,
two.
I'm going to put 2. So there'll be 4 minus
5 times 2.
5 times 2. Which is?
4 minus
6.
10, which is
Negative 6. Cool. One immediate bonus for this notation is what point would the graph of this function go through? I know one point it would go through. Anyone see what point it would go through? When I have an input of
2,
2.
negative 6.
Yeah, so it would go through the point 2, negative 6, right? This function happens to be a linear function. I can make an XY table. I can talk about slope and all that kind of shit. But just the idea of what function notation is, right? Okay, let me push this a little bit. What is f of w?
It's,
Math, very single-minded. Yes.
4 minus 5 times W.
Kick ass. I mean, that's all f does. What does f do? Whatever you put there, I'm going to put it over there. That's what I'm going to do. The difference here is, can I simplify this?
No.
No, of course not. No like terms. Okay. Anybody freaked out about that? So The idea of function is whatever you put there, I'm going to replace the variable with it. Whatever I put there, right? Yeah, maybe.
And so can you find multiple points with that?
Well, you have to input several things. Sure.
Okay.
So I could find f of 0. What's f of 0?
Um,
4.
Four.
So I got the point 0, 4. That's the
Uh-huh.
y-intercept.
Oh,
right?
okay, got
F
it.
of 1, f of 2, and then I can plot the points, blah, blah, blah. Yes? Okay.
And can you take points and make it that?
Do what now?
Can you take, like, if they give you points, can you make it that equation?
Oh, I'd have to have enough information for the type of equation it is. For a line, I need 2
Okay.
points, right?
Uh-huh.
Because then I can get the slope and the y-intercept, yes?
Okay.
I like it. Man, some of you guys look dejected. I'm really sorry. So again, if we're not done yet, but if anything I've done has gone over your head or anything, you need to go to tutoring, you need to see me in my office hours, something. Right? A lot of my colleagues just skip chapter 1 and 2, and I think that's not the right approach, because then these things just suddenly come at you out of nowhere later. Right? So we are going to see some of these ideas again, and when we hit them, we're going to kind of review them a little bit, but just want to give us a ground floor to work off of. So the real power of functions is if I have f of x is x squared minus 1, and I have g of x is 3 minus x cubed, and I have h of x is 4 over 2 minus x. So it's much better than y, because then if I said x is 3, what's y? You're like, well, which freaking equation? But now, there's no question. If I say what's h of 1, you know which equation you're going to use, right?
Yes.
The freaking h equation, right? And what do you get?
2.
4.
4. Okay, 4 over 2 minus 1, 4 over 1, 4. Okay.
Oh, yeah.
Right? What about h of 2?
It's no solution.
It's not an equation. Not an equation. No solution is the correct answer to an equation.
Undefined?
This is undefined.
Undefined.
This number is undefined. The number this is trying to be is undefined.
No.
I like it. And again, if you mix those words up, I'm not going to like take 20 points off or something. Just 19. No. But I want you to see the different situations. Okay. Oh yeah, we got time. Look at me. And you're like, no, Jeff. That clock is slow, man. What are you talking about? Too bad. Oh. So what would you say the domain of h of x is? This is funny because this is kind of a question that came up earlier.
Kind of forgot
What's the
what
word
that is.
domain mean?
Like their area?
I remember that there was a thing where it's like the x, like one of them involved the x and one of them involved y.
Beautiful. Anybody remember
Well,
which
like
one?
the range, but not the range, because the range is
But I
something
don't
different.
remember. I don't.
Isn't it just like the points for like the graphing points?
So the domain is all the x values I'm allowed to use. More generally, it's all the inputs that have outputs.
Oh. and
The
this
range is all the
the-
outputs, right? So
Oh.
domain is all inputs that have outputs. And the range is just all the outputs. So to figure out the domain, we very often think backwards. What can I not use? And we just discussed this. What can I not use for this function?
2.
2. So the domain would be, remember this? Somebody asked a very timely question earlier. Everything
I do
except
not
2. That's
remember
basically what that says.
Uh-huh.
What does this mean? What does this mean? Negative infinity to infinity. That means all real numbers, correct? It means all real numbers. So to see how that's what's here, this piece just means skip. That's all it means. Negative infinity to infinity, skip 2. If you look at it like that, it's a little bit easier to kind of like figure out what to write. So for example, what about this function here? What do you got, Jeff? There, okay. Shit. What do I?
We should factor the bottom.
Beautiful. How do you factor the bottom?
It's gonna be
Not 9 and 2, right?
And positive.
Plus 3 plus 6.
Plus 3
Negative.
minus 6. So it comes out negative if you like. So now how many values can I not use? What's not in my domain? So I can write like this. X can't be what? Negative 3
Or oh, got
or
it.
6.
Yeah.
How do I write like this? Like this, you ready? Negative infinity, stop at negative 3, skip 6. Do you see how you just kind of repeat this shit for whatever I have to skip? Negative infinity, skip negative 3, skip 6, keep going. That's all that means, right? Maybe. So that's the interval notation way.
So there are going to be problems where the answer is all real numbers, right?
Totally.
Okay.
Yeah.
And that would be like
Here, I'll show you.
If-
I'll show you one real quick. A fractional one. Obviously, if I have a of x equals x squared plus 2, what's the domain? Is there any number I'm not allowed to use? Any number I can't square? I can do anything, right? So what kind of things are going to make something that I can't use? Fractions, where the variable's on the bottom. How about let's do a nifty. So this would be all real numbers, right? Let's do a nifty one. B of x equals the square root of 3 minus, no, let's not make it too weird, Jeff. X minus 1, there. Now, real quick, I want you to realize, when I did this problem, you guys did something and didn't notice you did it. What can't happen? The bottom can't be 0, correct? So if you just say bottom cannot be 0, and then solve that, you've got the domain. What cannot happen here? What kind of number has to be in this to keep it real? Or 0. So the inside has to be at least 0. Is that cool? You can say in words what needs to happen and then write that in mathish. Solve. How do I solve this?
mathish. Add 1.
Add 1. So x has to be greater than 1. Does that make sense? If I put a 1 in, what do I get?
0.
0. That's the smallest number I can take a square root of and stay real, right? So in general, if I write a function down and I don't say, I'm assuming it's only real values allowed. The problem would have to say if it was allowing complex values.
Why would it be x minus 1 has to be greater than or equal to 0? Because you can't use square root of 0?
What kind of number can you put inside of a square root and it stays real? What kind of number makes it not real?
Negative.
Negative. So what kind of number lets it stay real? Greater than or equal to 0. What's the opposite of negative?
Positive.
No.
Oh,
Positive. Oh wait,
What?
was it?
what's the opposite of
Yeah, what's the opposite of negative? It's not positive.
um?
One quick answer is non-negative, right?
Yeah.
But it's 0 or more, because 0 is not negative, is it?
Okay.
0 is also not positive, is it? You with me? You could also think of it as being both, but we don't really know.
Greater than or equal to 0.
So I want you to really understand why. So one reason is why it isn't this, because 0 still works too, right? What could this be? What's the smallest this could be? 0
1.
or more. No, not x. This whole thing.
Oh.
What's the smallest number I could put here? 0.
Yeah.
So that means that this has to be at least 0, correct?
How do you take the square root of 0?
No, but wouldn't it be
Stop.
negative?
What's the
Oh,
square?
the whole
What's the
thing.
square root of 9?
Okay.
Because 3 times 3 is 9. What's the square root of 0? Because 0 times 0 is 0. So square root of 0 is 0.
Oh. Yeah. I'm
Zero,
getting-
zero, zero. Yes.
So you're saying the whole x minus 1 is greater than or equal to 0,
So,
not just.
When I see this, I
Yeah.
think of this as one number. Because if x is 7, that is the number 6.
Okay.
So what could I make this number to make the square root work okay? At least 0. That's why I wrote.
Yeah.
This number has to be at least 0. And then I solve it. Yes?
But wouldn't 0 make it negative 1? And that would be.
No.
No, because the
This
whole
number,
the whole thing is
this
0.
number has to be at least 0.
Oh, okay.
Which means x has to be at least 1.
Alright.
Okay. Nothing but exciting. All right, that's plenty, guys. Go ahead. I hear you packing up. It's time.